Good morning, and thank you for joining us for our webinar with OutBack Power. Today we'll be doing an introduction on the Mojave ESS. Before we begin, if you're experiencing any technical difficulties, please notify me by typing your question in the question section of your control panel on the right side of your screen. And I don't see any coming through, so I think we're all good to go there. We will have a Q&A session following the presentation. You are welcome to submit questions at any point during the webinar, and we'll do our best to answer as many as possible after the presentation. Any of those that don't get, answered will be followed up upon. There will be a brief survey that'll pop up in a new window immediately following the webinar. If you wouldn't mind taking a couple minutes to complete it, as a special treat, we will email you a copy of the presentation as well as the link to the video recording. If there are no questions, which again, I think we're clear, I'd like to introduce Chris Canfield, the Regional Sales Manager, and Paul Daly, Director of Product and Market Strategy from OutBack Power this morning. So without further ado, Chris, I'd like to pass the baton right over to you.
All right, thank you. And thank you everyone for making the time this morning to attend. We're real excited at OutBack to have something that's a new product, a completely new platform. I'm assuming that a majority of folks on this call, on this webinar, are familiar with the products that we've had. Some of them we've had for 20 years, as a lot of you know, which is both good and bad, right? It means that what we're making lasts and works out in the field. The negative is we need to get something new. Well, we do have something new to introduce to you today, and we'll be introducing it in stages, if you will, probably over the next 6 to 12 months. And I'll get into, and Paul Daly will get into what I mean by that. This is the introduction of the Mojave ESS. This is not going to be deep dive into installation. That is going to be part 2 of the webinar, which is going to be in a couple of weeks, and Aaron will take care of the invitations for this afterwards. For attending this part 1, this webinar, your name will be entered into a drawing. I'm sure you've seen this on the invitation for the webinar. You'll be entered to win one of the AC coupled Mojave ESS units that AEE will be receiving from us very shortly. We're getting ready to send out the first batch of the Mojave ESSs for AC coupling. So you got a chance to win a free one, which is nice. First of all, everyone's favorite confidentiality terms and disclaimer. I'm going to read this word for word. I'm kidding. This is probably enough time for you all to see it. As Jeff Spicoli said in Fast Times at Ridgemont High, learn it, know it, live it. So this is the agenda for today. We're going to talk about OutBack Power. We are going to get a little bit into the background of OutBack. Again, I'm certain that a majority of you know that, but I always find it interesting when I look at the background slides before I present them, like, oh, I didn't know that, or I didn't remember that. Increased demand for ESS, AC coupling, a review, as again, that is what Mojave is approved for right now, is AC coupling. It will be approved for other things down the road, which again, we'll get into. Then Paul will take over and do the introduction of the Mojave ESS. We'll have Q&A at the end. And Paul, by the way, is the direct product manager for the Mojave. He's been with Mojave since day one. He knows it inside and out better than anyone. So he's the right guy to have do the introduction and the specifications and things like that. First of all, just a little background about EnerSys. EnerSys purchased Alpha, which OutBack was a part of in 2018. I'm sorry, it was 2018 when we were purchased by EnerSys. So we are an EnerSys company. Reserve power, motive power, aerospace and defense. EnerSys is everywhere with storage solutions and with batteries. We have 19% market share globally, $2.6 billion in revenue in 2018. We do business in over 100 countries. We have global manufacturing facilities. We have almost 10,000 employees worldwide, and the majority of what we produce and sell is indeed recyclable, which is always a good thing to talk about. So a little bit of background on OutBack. 2001 is when OutBack was formed, if you will. Some of you may remember, but it came as some guys from OutBack, engineers at Xantrex wanted to do something new and different with the inverters that Xantrex was selling. They were told no, to basically pound sand and to go back in their engineering building, which happens to be OutBack. So that's where the name of the company came from. We introduced the Flex Power in 2010. The Flex Power is still one of our best selling systems, whether it's a Flex Power for off-grid, a Flex Power for grid tie with the Radian, what have you. The Flex Power is basically the first attempt and successful attempt in the industry to make installing storage systems simpler. What we did and what we still do, of course, is we pre-wire the systems, the Radian or the inverter charger, along with the charge controls and communication equipment, just trying to make it simpler rather than having to be installed piece by piece, which obviously still happens a lot as well. In 2010, OutBack joined the Alpha Group, which is a way of saying Alpha acquired OutBack. Alpha is also a Northern Washington-based company that does a lot in the storage space, not necessarily like we do in the renewable space, but they do a lot of it. There were a lot of connections between the two companies, and hence Alpha acquired OutBack in 2010. The Radian, which is still our best-selling inverter charger, was introduced 11 years ago. I like to point that out because there's not a ton that lasts that long in this industry, especially in the power electronic space. Modules, sure, modules are modules. They get bigger and better and more efficient. But technology changes, and technology has changed with the Radian over the last 10, 11 years with firmware upgrades and what have you. But the Radian is still going strong and is still currently our best-selling inverter charger. Optics RE, that's our communication platform that was introduced in 2014. In 2015, we expanded the energy cell storage line. What that means is, in short, we added batteries to what OutBack sells and made it more of a complete package that we are able to sell. And we continue to be that, and especially now that we're part of EnerSys, we have access to a lot more batteries than we ever did before. Again, 2018, we were purchased by EnerSys. And 2022, that's this year, the introduction of the Mojave ESS, which is what we're talking about today. Some background, increased demand for solar storage. Again, a lot of the people on this webinar, I'm assuming, already know these kind of things, but there are the traditional uses of energy storage for which OutBack is still sold and installed, which include remote off-grid applications, telecommunication, remote homes, of course, off-grid homes, and water pumping. We still are big in this space. I would say we dominate in this space, actually. Newer uses of energy storage, on-grid applications, right? Energy resilience, time of use and peak shaving, often due to changing net metering policies, meaning, okay, from 3 until 8, I'm in APS territory in Arizona. From 3 till 8, we've got the peak rate plan, so if we were to have a storage system, that would be when we would want the battery to take over. We wouldn't want to be, or we would want to be buying as little as possible from the grid. And we're seeing that all over the country now. It used to be kind of it's a Southern California thing. Not so much anymore. You're seeing that a lot of places around the country. AC coupling to new systems and adding storage to existing systems happens a lot these days, right? I mean, that's the Tesla market. And I read something yesterday that Tesla still is having over 100,000 systems installed a year. So that's obviously a combination in adding the storage component to an existing grid-tied system, or building, if you will, installing from ground up an AC coupled system, which, what we've learned, what we've heard, that's about a 50-50 proposition, the build up versus the adding to. Sometimes that's due, sometimes AC coupling is necessary the storage is added happens a lot, or AC coupling is just installed due to utility shutdowns. As we know, PG&E is famous for that. There are other utilities now, including most recently, it happened in Nevada, where there was a big windstorm, and NV Energy decided to shut down the power in certain areas for certain times, mostly up in the mountains, but still more and more utilities are doing that when there's going to be a weather event. Obviously, the liability of what happened in California and the entire town of Paradise burns. No utility wants that to happen, so the shutdowns are happening more and more often as well, and that's a great place to have AC coupling installed. Just a little bit of market background and obviously estimates, as 2021 data isn't in. Pretty much you can just see how much storage has grown. The residential space, which is where OutBack plays, is this darkest blue, the bottom of each of these bars in the chart here. And you can see how that's really gone crazy since 2018. I've been in the industry myself since 2010. And I've always heard, oh, storage is the next big thing. It's the next big thing, next big thing. Well, for 8 years, it was the next big thing. And now it is the big thing. It's here for certain in both the residential and the front of the meter space, obviously. Okay, a quick review of AC coupling and what AC coupling is. As again, Mojave is specifically for AC coupling. So our starting point is this, let's call it a grid tie system. Where the grid tie inverter is connected to the main panel, the load center, and the grid provides the reference voltage and frequency needed for synchronization, meaning the grid tie inverter needs that signal to work and to allow the PV to pass through it. We all know this as far as the UL specifications and what have you, that when the grid tie inverter shuts down, that the grid tie inverter does shut down when the grid goes out. Grid goes out, that signal's not there, grid tie inverter goes out, PV doesn't do you any good. A lot of people, again, discovered this when they had PG&E pull the plug for 3, 4, 5 days and they had solar. Y'all be surprised at how many people didn't realize that the solar, the grid-tied solar system that they had on their house didn't provide power when the power was out. But again, all of us on this call know that that's the case. Obviously, there's no ability to store the energy for off-sun hours and or when the the peak rates may be there. So AC coupling is basically, again, it's either installing a storage component with a grid tie component or adding it, which can be done fairly easily, after the fact, after there's, say, been a grid tie system in place for a while. The output of the grid tied inverter connected to the Mojave protected load panel, and obviously the Mojave is also connected to the protected load panel here. Surplus PV is saved in the battery, meaning the PV that's not feeding the loads. The loads, okay, they're being 100% served. The PV then will go to the Mojave, which will charge up the battery. And once the battery is fully charged, you're exporting to the grid. So, in some respect, the Mojave and the Mojave acts as a bit of a pass-through. It certainly does when the battery's full and the loads are being served, so that the system can still, net meter or turn back the meter or, feed the PV meter, whatever. We have a system on our home, and it's 2 different meters. So it can serve as a pass-through for the grid tie system. And, as long as there's no outage, that's what it's going to do. And you're basically still going to get the full benefits of having the grid tied system. The AC coupling component, the AC coupling benefits, the benefit of having AC coupling comes into play when the grid goes out, in particular during the day. Like, as we know, when there is no storage component in place, when there's no AC coupling, the grid goes out, there's nothing, right? Your house is not getting any power, even if you have the grid tie system on the home. And we always have an illustration of a grid tie inverter here. This can obviously, be microinverters as well. So I refer to grid tie inverter. You can think microinverters if that's what you're used to installing or AC coupling with. The grid tie inverter is either microinverters, which it more commonly is these days, or an actual, string inverter. So the Mojave automatically isolates itself and the grid tied inverter from the grid to prevent backfeed, right? That's what it does when the grid goes out and there's PV. This is the important part. It provides the grid tied inverter the voltage and frequency needed to operate in lieu of the grid. So in some respects, the Mojave becomes the grid when there is no grid, providing that 60 hertz and that correct voltage signal back to the grid tie inverter to trick it, if you will, into thinking, okay, I've got grid, I can keep working. And if I can keep working, I can keep taking PV and I can keep feeding the loads, the protected load panel, I can keep protecting the loads with the PV. The protected loads obviously are served both by the grid tie inverter, this is when the sun's out, of course, and the Mojave as needed. The main panel's not served, that's over here, that's on the side that's shut down, right? The Mojave can charge the battery using the surplus power from the grid tie inverter. So once the loads are being fully paneled, that power continues over to the Mojave. The Mojave uses that power to charge the battery. The Mojave uses frequency shift technology to shut down the grid tie inverters when the battery is full. In other words, when the loads are being fully powered, when the battery is fully charged, there's no grid to export to, you have to shut down the system.
99 times out of 100 they are there. However, today we had to cancel because.
Oh, sorry, someone's chatting. I thought I had a question, but I'll continue with this. Mojave uses the frequency shift technology to shut down the grid tie inverters when the battery is full. What does that look like, or how does that work? Basically, the Mojave incrementally steps up the output frequency as battery reaches full charge. When the grid is not available and surplus PV, quote unquote, has nowhere to go. So I've got this same illustration down here. Again, there's no grid. Okay, the loads are being fully powered. Okay, the battery is fully charged. Now what? Well, the Mojave steps up the frequency that it, quote unquote, feeds back to the grid tied inverter from 60 hertz, which of course is, nominal frequency and the frequency that the grid would normally provide, steps it up to, if needed, all the way up to 64.5 hertz. Now, often, even before it gets to 64.5, the grid tie inverter will shut down because it recognizes or thinks that the grid, even though the grid is the Mojave, is out of whack, and UL needs that grid tie inverter to shut down when the quote unquote grid gets out of whack. So it basically tricks the grid tie inverter into going off and not accepting, if you will, the PV to make sure that electricity doesn't go God knows where. So that is how it works. It's real slick. It's very fast. It sounds like it's a gradual thing, but it's really pretty quick. The frequency shifting up to 64.5 hertz is needed, and bang, that grid tied inverter going down. And that's a technology. This frequency shift technology is something that we've been doing for a while with the Radian. It's just done in a bit of a nicer fashion, if you will, with the firmware that's on board the Mojave. So that's your review of AC coupling. The main use of AC coupling, again, is tricking that grid-tied inverter into working when the sun is there. At night, when there's no grid, it basically, the Mojave kind of acts like an off-grid inverter, right? Just from the battery, just powering this particular load panel. But that's what makes it key to be able to have AC coupling and charge that battery up at night is, again, let's say it's a utility outage that's going to last multiple days. During the day, you need to charge up that battery so that at night you at least have some power available to use, because you're obviously not going to be getting any PV when there's no sun to get it from. AC coupling can also be done off grid. This is the only slide I really have on it. I don't know how often it's done. That would be a question I would have for you. I know that it is done though, where you can indeed AC couple off grid. Say you want to install in-phase inverters and the Mojave and have it off grid. You sure can. You can use the generator as a secondary charging source, but it is absolutely okay to do. And our application engineer, Mark Mays, likes to say that, Mojave is really the best for AC coupling off grid for certain. So that can be done. AC coupling can be done off grid as well. And with that, I'm going to turn over the presentation to Paul. This will be where Paul will get into the features and specifications. Paul is the Director of Product and Market Strategy. And like I said, specifically, he has been the product manager for Mojave since its inception, since it was an idea. And now we are bringing it to market. All right, Paul, I'll turn it over to you.
All right, thanks, Chris.
You bet.
So what we aim for here is a much more kind of consumer-friendly design, I think, than you've seen from a lot of OutBack stuff in the past. We're getting to a more streamlined platform where everything's in the box. You don't have a bunch of components that you're mixing and matching anymore. So this particular system, 8 kilowatt continuous output inverter, 15 kilowatt hour battery. We've got, we paid some industrial designers to make the whole thing look nice, like it belongs together. And we've engineered the whole system for more kind of energy management, as well as our traditional, backup and off-grid uses. So the entire system is warranted for 10 years. The battery is 10 years or 46 megawatt hours of throughput. So whichever comes first there. At the end of that warranty, we guarantee at least 80% of the nameplate capacity. And then I don't know where the cycles actually aren't counted in the warranty. It's purely throughput. So I'll have to fix the slide, Chris. The other thing is we don't have a lot of exclusions on that warranty, right? So for a lithium-ion battery like this, we're not requiring you to be connected to the internet. We're not requiring that you report average state of charge or anything like that. We're just asking that you use the battery as intended and don't go outside the parameters in the manual. It's a very cost-effective, power-dense lithium-ion battery. So what we've done is we've taken a battery that was developed for EnerSys's forklift market. So these are batteries that you have people sitting on top of and driving around all day, abusing far beyond anything you're going to ask a stationary storage system to do. The system itself is listed to 1973 as well as 9540, and then UN 38.3, which is transportation requirements. And then the underlying cell and module design, came through, again, that forklift product, which was tested for all the automotive and EV standards, right? So in addition to all the abuse that you do for a stationary battery safety test, the underlying modules that are inside this package have also undergone, pretty substantial drop tests, impact tests, and the like. One thing to point out for folks that have installed a lot of OutBack, this is a completely new platform. It's not compatible with the legacy products like the Radiant or the Mates or any of that. And the reason for that is we've gone away from our proprietary OutBack, Mate hub model for communications to something much more standardized. We're using TCP/IP, Modbus, CAN bus, the types of communication protocols that allow us to interface with third-party devices much more easily. Next slide, please. So basic specifications, as I said, 8 kilowatts continuous power. We have max current output up to 42 amps, which is obviously a little more than 8 kilowatts. I'll get to that in a second. And then we have a power control system built in. So we're still in the process of getting this certified. That'll be as we do our next round of certifications next month for SB or Edition 3 or 1547 2018, however you want to think about it. Basically the requirements for California and Hawaii that are going to come into effect this summer. We are already setting up to test that, and we know the product can do it. But part of what we're going to add when we do that is the power control system certification. And what this does for you is it allows you to modulate the inverter down using the included CT so that you can tell it, make sure that that this CT never sees more than, 7 kilowatts from the inverter, or 4 or 3.5, or whatever the number happens to be. And that allows you, because of that certification, you can size your overcurrent protection and your wiring accordingly. So you don't have to size it for the maximum the inverter can put out. You can size it for what you've told the inverter it should put out. Also motor start capacity. So we're doing things a little bit differently than others and than we have in the past. So we have a 10 kilowatt transient load service. What we actually do with that is, when there's a big load, say like a compressor in a refrigerator, or a motor in a pump, whatever those things are, typically what they need is they need a lot of current. And so what we've done is, without just jacking all kinds of power into that, which gives us problems with the aforementioned power control system requirements, what we do is we control the power to 10 kilowatts or below, and we basically let the voltage fall and hit it with enough current to get that motor started, or kick over whatever that inductive load is that's going to suck up all the current. So this happens within usually 5 to 25 cycles, and what you'll see if you look on an oscilloscope is you'll see the voltage kind of drop down from, say, 120 to like 105, and you'll see the current go up to, say, 60, and in some cases even higher amps for the cycles it takes to get that thing going. And because we can keep the power down, you're not overloading anything. So in addition, we can basically start pretty much all the same loads. You can start on a Radian, and we're going to be releasing videos and tests and things to demonstrate that, but in a way that's much more friendly to the loads, as well as all the electronics. In addition, we're also planning to add revenue grade metering along with the PCS. It does all of this today. We just don't have the cert. Nominal 48 volt battery interface. So there aren't a lot of 48 volt battery platforms out there, or excuse me, inverter platforms out there. And the reason we stuck with 48 volts for this product is we do intend to offer the inverter a la carte at some point in the near future. And then you'll be able to pair that with traditional lead acid batteries, as well as with the Mojave battery. So the inverter and battery obviously have a CAN interface, which we use to communicate. I do get a lot of questions about, hey, are we going to work with other batteries? The answer is probably, but we're going to have to take it one at a time on a case-by-case basis, because each one has its own little special things you have to program in, and that takes time and effort and investment on both our part as well as the other side of the equation. So charging from AC sources. So we've got a port in there for a generator. One difference here is that we don't ship with the generator circuit breaker in the system. It's just, we found that a lot of people aren't doing generators these days. And so rather than burdening everybody with that cost, we've just made that circuit breaker an accessory. It takes about 5 minutes to wire it in, but you can put that in there. We've got the port on the boards and everything. So if you want to hook up a generator, no problem. You can put up to 32 amps into the system to charge batteries and so forth. That'll pass through the rest. And of course, with AC coupling, you're going to have your AC coupled grid direct inverter. That is going to be wired to the same circuit as the output of the inverter. Next slide, please. So applications, we said this is really heavy duty backup, off grid. This is an OutBack product. It's designed for that kind of use. Obviously the generator integration, as we mentioned. And I think the most popular one is likely to be, retrofitting to a system that already has a grid type PV system. This is an AC coupled unit. In most cases, you shouldn't even have to go on the roof. You basically just mount this thing in the garage and change, take the AC PV inverter and wire that into the protected loads panel that you're wiring the output of the Mojave into, and you're basically good to go. So we offer then your standard kind of energy management stuff. We've got self-consumption, obviously. So if you're you want to limit your export, there's a caveat on AC coupled with that, in that if you're going to limit the export from the grid tie inverter, once the battery is full, there's not a lot we can do about that. So you'll have to have some device on that grid tie inverter that limits export if you're in that situation. But as far as the rest of it goes, you can prioritize charging the battery before that power gets sent back to the grid. And then of course, time of use. So you want to use from the battery during peak hours instead of from the grid. And then similarly for demand charge mitigation, I live in Phoenix. We have that. It's usually coincident with time of use, but in any case, you can input a maximum current from the grid, and then anytime the unit sees, with that CT at the main, anytime it sees more than that coming in, it supplements with the battery, so it keeps you below the threshold. So as Chris mentioned, this is really the only AC coupled product that I know and that our application engineers have said they would recommend for off-grid use. And there's different reasons to do that. If you want to have module level power electronics, that's probably the easiest and least expensive way to go about it, is to put in this with something like that. And so it'll treat the battery just fine, as opposed to having to be DC coupled. So the main difference here is we've really done a lot of work on the AC coupled side of this, and it controls that output just as well as a DC coupled product does. So as I said before, we've updated the communications protocols, so there isn't any backwards compatibility. And to forestall a question I expect will come up, with the AC coupled unit, you will not be able to add a charge controller to it. We'll get to it a little bit later. We are working on a DC coupled variant, but for this unit, it's AC coupled, and that's what it does. There won't be any way to update it in the field until much later. So next, so US assembled product. The inverters are assembled in Bellingham. Components come from all over the world, so I can't say it meets Buy America Act necessarily, but it's certainly made in America. That's point of origin. The battery is built up in Spokane, Washington, just a little bit down the road. Similarly, components come from all over. That gets built up there, shipped from there. Everything will ship out of Spokane. So we'll talk more about that in a little bit. The idea is you have a complete solution, right? So you'll get this thing, it all ships out together. Everything you need is in there. You've got a nice, cost-effective, power-dense NMC battery. So the form factor on this battery is it comes out about a foot from the wall. It's about 2 feet wide, and then the inverter is designed to mount directly over the battery. So yeah, the whole thing's about 7 feet tall, but you've only taken up 2 feet of wall space and 2 square feet of floor space, which for a system this size is about as small as it gets. It is transformer based. We did that basically to preserve the kind of robust features that people expect from OutBack products. So this was designed by our team up in Bellingham, including folks that are actually on the IEEE panel that writes the 1547 grid interconnection standard. So this was designed from the ground up to meet not only the 2018 version of that, but also the stuff that we know is coming. So future-proofing that platform and making it much more accurate and precise for these things that are coming down the road. The inverter unit is completely field serviceable, so I believe every board in there can be replaced in the field if necessary. So if you have a long service life planned, we got you covered there. Every inverter has its own built-in Wi-Fi hotspot. So you'll see a little antenna hanging off the side of there. That's what that's about. You don't necessarily need internet service to access the UI. because it's broadcasting that from a web server that's built into the inverter. But you'll want to have a device, a phone, tablet, laptop, whatever, with Wi-Fi, so that you can log in and see the UI. We talked about our voltage and current response for motor start. Basically, you can start the same kind of loads you would start with a Radian. You can do with this. It's just a little bit more friendly about it. And then you can do 3-stage charging, even though it's AC coupled, right? So it's not the bang bang charging. We can do the whole, bulk absorb, etc. Grid zero, we don't have that called out as grid zero, but basically you can tell the system not to charge the battery from the grid, which is important if you're in California and other states where that's an issue. And then of course, adding a generator is about as easy as it gets. So just to compare it to the Radian, you'll see we've got the 4 kilowatt and the 8 kilowatt versions of the Radian with the regular FPR as well as the AC coupled bundle. It's pretty similar in terms of the applications it's designed for, but because we have that CT and that CT is delivered with the unit, you don't have to buy it as an accessory. It comes in the box. You wire that at your service entrance, and now you can manage the loads for the whole house regardless of what you're actually putting on your protected loads panel. It is still indoor rated, and it's AC coupled, rather than DC coupled, up to an 8 kilowatt PV inverter. We are doing some testing to see if we can go over that, but we're not making any promises just yet. And of course, we have the freq watt support where we can modulate that PV inverter up and down, and very good voltage regulation on the battery. So if you're AC coupling, we definitely recommend Mojave. Part number is OGH ESS 8015A, and what that means is it's OutBack grid hybrid energy storage system, 8 kilowatt inverter, 15 kilowatt hour battery. The A just actually means it's North America, so it's a 120 240 split phase, and then the DC coupled version will have a dash PV when we launch that. So speaking of, we expect to enable stacking here sometime over the summer. So we're working on the firmware. We've done some successful tests, and now we're just kind of getting into implementation. So we'll start with 2, then 3, then 4, and kind of ratchet it up as we go and get more test results. But the way that we're handling the stacking is novel, and I think the way that you'll see a lot more products come in the future, as it will enable much better microgrid operation, as well as it's friendlier and more capable for grid services and the like. So the PV version, you'll see this little built-in charge controller. The picture's a little misleading. That's actually going to be the same width as the battery, so you'll have both units be 2 feet wide. It'll have that built-in charge controller, 3 channels, 600 volts. You'll be able to put upwards of 12 kilowatts of PV on there, and that'll be able to charge the battery directly from PV. After that, we'll kind of move our focus to more kind of accessories and for the rest of the house. So, whole home backup and energy management, load controls, all those kinds of things are stuff that we're starting to explore right now, but probably won't be able to launch until next year.
Sure. And Paul, I'll just ask a quick question here. We expect once the DC coupled version is available, and hopefully we're still shooting for around SPI, so that would be September, October of this year. We're anticipating that although the Radian will not go away immediately, we're anticipating that the DC coupled version of this will indeed take over, if you will, the space that the Radian currently owns, correct?
Yeah, to be very candid, one of the reasons we embarked on this project is the IEEE 1547 standard was updated in 2018, and some of the requirements, particularly around precision on the controls and some of the communications protocols, the Radian has an 8-bit processor. There's just no way to make it do those things. And so that was the raison d'etre, if you will, for kicking off this product, among other things. But what that means practically is, starting in the back half of this year in California and Hawaii, you're going to run into trouble from utilities and AHJs allowing you to interconnect the Radian because it can't do those extra special things you're supposed to be able to do with this new standard. That will probably be nationwide by the end of, say, 2023 or 2024. So the Radian will work totally fine off-grid. It'll still do all the things it does today. It's just you're not going to be able to get your interconnection agreement in some states, as they adopt this new standard, and that's why we'll be transitioning to this platform. We're going to manage that transition carefully over a fairly long time, so nothing's going away tomorrow. But my advice is get familiar with this platform. It's the go forward thing, and I think it'll be easier on everybody. I think once you install one of these, you'll get it and say, hey, this is way easier anyway. It's going to be more cost effective, and so that's what I expect going forward. But we're not taking the Radian away anytime soon. It's going to transition, and we'll make sure that everybody's got access to it for as long as necessary. So as I mentioned earlier, the ESS, it's a single SKU. It ships on a single pallet. So you'll see kind of here how it's packaged. The kind of big box in the bottom is the inverter. The tall one is the battery. And then this box here is the battery cosmetic covers, as well as integration hardware. So it'll show up all cocooned in shrink wrap, and then you'll install it over the top of each other. There is not shown in the picture. There's actually a raceway that we've added between the battery and the inverter. It's about 6 inches tall, so that's the recommended clearance. That'll be more important when we have the DC coupled version because there'll be a fan down there that you'll have to have clearance for. But that raceway will act as kind of a spacer. We also set up the bracketing, so it's the same mounting bracket as the Radian. So if you're installed that cleat, it's the same exact system. And then we've given some tools to align that with the wall anchors for the battery. The battery's floor mount, but we do provide wall anchors for just anti-tip and that kind of thing. So lots of good resources. You'll keep an eye on our Mojave landing page on the website. So if you go to outbackpower.com and you'll see the big hero image for Mojave. If you click on that page has got all of the up-to-date resources. I know I did watch last night. Jorge has done a Watt School video for commissioning. It's quite good. So this whole series that he's putting together kind of walks you through everything from receiving the unit to mounting it to wiring it to commissioning it, and then he's going to start doing how to do all the cool pet tricks that you can make the system do.
Yep. And Jorge will be part of the second webinar that we do as well. He'll be on board. He's got one of these on his home, as does the other gentleman that will be joining us, Lonis Tuss, for the next one. So we'll get more into installation tips and how it works and how it worked for those guys, and they'll go through the GUI and stuff with us next time as well. Jorge will be one of those that'll be on.
Yeah, so one note, if you see some of these pictures are of our field trial units. The field trial units, due to let's be honest, call it a mistake from our casting house, have the cool Darth Vader covers. That's not the way that units going forward will ship. But they were perfectly functional. They were just the wrong color and finish. So we went ahead and used them for the field trials. So those guys will have limited edition, Darth Vader edition Mojave units.
And that's it. We timed this out really well, Paul. I got 10:44. I know we were supposed to leave 15 minutes for Q&A afterwards. So Paul, obviously stick around, and Aaron, if we turn it back over to you for this section, let's do it.
Perfect. Thank you guys. And I am trying to bring up our questions here. Looks like we have a few. I'm trying to open them. Okay, so it says, let's see. Give me a second here. There's quite a few, so I'm trying to make it a bigger window. Okay. There we go. Okay, will the Mojave ESS inverter work without batteries under case when batteries have failed or prior to installing batteries? And you may have answered that if that came in, but figured I would bring it anyways.
Yeah, the short answer is no. It's a battery inverter. You need to have a battery to operate it.
Yep.
Okay. Wondering if the Mojave battery will have a UL 9540A thermal runaway certification to allow installation inside living areas. This is an inspections requirement in my jurisdiction. Worth mentioning, the surge capabilities of this unit are great for rural customers who very much would want their water pumped during grid down situations.
So 9540, we do have a 9540 listing on the battery. It is, there's a bunch of stuff going on, and I think what they're referring to is what I call the unicorn mark, which is if you pass the cell level test in 9540A, which is basically a test that's impossible for any current battery chemistry to pass, then you can install it in habitable spaces, right, like bedrooms and closets and so forth. We're not going for that. Nobody with any sense is going for that. The requirement, if you read the code, basically, if you have that, it accepts you from the placement requirements. A regular 9540 listing like we have is sufficient for installation in a garage or a utility room or other what's called non-habitable spaces in the dwelling. I am actually spearheading an effort with the Sustainable Energy Action Committee and CALSA to get 9540 updated. And then those same groups are also working with the ICC to have a corresponding update in the residential code. So basically the way it'll read going forward is you'll say suitable for residential use in habitable spaces or in non-habitable spaces. So our mark would be for non-habitable spaces.
Okay, perfect. Thank you, Paul. What is the low temperature limit for warranty? Many other companies have a 41° Fahrenheit limit.
So like cold temperature, you mean?
Yeah, low temperature.
Yeah, sounds like what they're asking is like, what's the coldest that you could have it around and still be under warranty?
Okay, so the inverter is good to about -20, right? So that said, the battery will only operate to freezing. If you're below freezing, you won't be able to charge or discharge the battery. Now that's the battery gets below freezing. One thing with lithium ion batteries is they don't have quite the thermal mass of lead acid batteries, so they do get colder faster. And so I recommend if you're in a place where you're concerned about long periods of very cold weather, and you want this principally for backup, you're going to be better off with a lead acid battery because it's just going to survive better in that environment. If you get the battery will survive down to -20 as well. However, it will not be functional whenever it's below freezing. And that's true of pretty much all lithium ion batteries, and the ones that get around that basically have internal heaters and stuff inside them, which we don't have in this unit at this time.
Perfect. And similar question, altitude limit for warranty?
I think we have the standard 2,000 meters, and it's not you're not going to avoid the warranty if you install it at a higher elevation necessarily. What it means is that it's going to derate faster because there's less air density. It can't cool off as fast, and so your power outputs are not going to be as high as they would be below that level.
Okay. Let's see. We've got what you may have answered this because they came in during the presentation, but what is the hottest temperature for battery and inverter?
So the battery will operate full power up to 40 C and derated up to 45. The inverter will go up to 45 at full power and up to 50 derated.
Okay, and then from the same person here, it says what battery chemistry? That was around like the 9:30 mark. So I don't know if that helps or if you need more clarification there.
It's an NMC battery, so these are prismatic cells. Like I said, these are based on our forklift batteries. I know there's a lot of scurrilous talk about, oh, this chemistry is safer than that chemistry. The reality is a lot more complicated than that. We found that these particular NMC cells give us the best balance between, thermal management and energy density, et cetera. And because they're large format prismatic cells, we monitor every cell individually, and there is, a steel can around each cell, and then each string is protected by another steel barrier inside the module. We've gone through all the same tests that every other chemistry goes through and have passed them with flying colors. So that said, it's a nice, safe, energy dense battery.
And they've all been tested, like Paul mentioned before, they've all been tested to motive power standards as well. So these same prismatic cells are in fork trucks that people are driving around all day, and they've been tested for that. So they've probably actually gone through even a little more testing than the average NMC battery has for safety.
Perfect. And then this last one, it looks like we're still good on time. Pretty lengthy one. Okay, regarding the string inverter, this is a few questions within a question. Does it need to be frequency shift compatible, or does any string inverter work? It just shuts down when frequency is out of range. Basically, does this happen fast enough to not have to shed power to a diversion load?
Right. So we recommend that, when you're AC coupling, that you use an inverter that it's listed for grid support. So you look if you look at the UL market, it'll say grid support, and that's I think where they're getting with the frequency shift compatibility, because that was what grid support required. Some of the older inverters, I have a suspicion, and we're in the process of testing. SMA has always done frequency shift, for example, because that's how they controlled it with their Sunny Island. I expect we're probably fine with all of those. But if you're installing with, say an older inverter. Sorry, what?
I think that's background noise, Paul. I heard it too.
Yeah,
okay.
Sorry, I didn't say anything. Yep, go ahead.
Yeah, so basically, if you have SA, which is grid support, no problem. If it's an older inverter, you don't necessarily need a diversion load, but you're going to be back to bang bang charging because we don't have a way to modulate that inverter.
Okay, perfect.
Do a quick explanation on bang bang charging.
Basically, you won't be able to do 3-stage charging. You won't be able to control the power coming out of the inverter, right? So it's going to be charging at whatever that inverter is outputting, and then it's going to stop, right? Because basically what'll happen with our algorithm is it'll keep ratcheting up the frequency until the inverter modulates down or shuts off. And in the case of an inverter that doesn't modulate, it'll just go straight to shut off, right? And that'll happen within about a second.
Yep. So the key takeaway is no issues with any grid tie inverter or microinverters that are UL 1741 SA compliant.
Okay, that actually may have answered this next kind of question within this question is, do you have approval from Fronius to AC couple any of their string inverters? And then he follows with, I pitched this concept to Fronius back in 2014, and they told me that they would void the warranty on any of my string inverters where we AC coupled.
Yeah, so I can't control the warranty terms on the grid tie inverters. I can speak specifically to those Fronius inverters, as I'm sure Chris can as well.
Yeah.
The old IG Plus line was different from most other inverters in that it was a high frequency transformer based inverter. It was very sensitive in terms of how stable the grid had to be. And so in AC coupling situations, what would happen is the inverter would just never recognize the battery inverter as the grid, and it would keep shutting off and not turning back on. So you wouldn't charge your batteries, and the whole system would just not work well. And Furnace's response, I think not inappropriately, was to say, look, just don't do it. As far as I understand, the newer Primo inverters should be working fine, because again, they have to meet the frequency modulation standards. But that's an important caveat, right? If your grid tie inverter manufacturer says, hey, avoid the warranty if you try this, we can't stop them from saying that and avoiding your warranty.
Yep. I was at Fronius in 2014. I may have been the one to deliver that message.
It was all you, Chris.
Yeah, it wasn't me coming up with the message, believe me. It wouldn't have been me coming up with it. It might have been me delivering it, though.
It's like most things. I blame Chris.
It's a don't shoot the messenger situation, right?
Right.
Okay, so I think you answered that part of the question. Sorry, I'm reading through it. It's a long one, but seems like a good one. Okay. Three more questions. Hopefully we can get through these. How clean does the generator AC source need to be?
I'm not saying any regular like home generator will work, so we've tested it with pretty much Kohler's entire home generator line. The Generac ones are pretty similar. The only time you're going to run into trouble is if you're trying to get like a sketchy, Harbor Freight type generator hooked up to it. We have a frequency limit. I think we talked about that. Let me see if I can find it real quick. There is a range. 50 to 66 hertz, 211.2 to 264 volts. That's the input range. So as long as the inverter consistently stays within those rails, we can rectify it, it'll be fine. That said, we only rectify it for charging the battery. Whatever it is it's going to pass through to the loads, right? So if your loads can't take that, then you need to find a better generator.
Okay. We actually have quite a few that have come in, and I know that we've got a few minutes left, so it's up to you guys if we want to kind of power through some of them, and whoever needs to drop off can drop off. I'm not sure what your guys' schedule looks like.
I'm available to stick around for a few more minutes if you like.
Yeah, me too.
Okay. Then I'll just I'll just power through and see what we can get to, and then the rest, if you're still on the webinar and your question didn't get answered, I will go ahead and forward the unanswered questions to our great guys here at OutBack, and we'll make sure to get anything answered that went left unanswered, just due to time constraints here. So how soon would you expect to release more info on parallel stacking? Perhaps a single line perhaps a single line diagram.
Yeah, so we'll release all of that as a package once we complete our testing and integration of it. I expect that personally to be sometime in the May or June timeframe. Like I said, we've got a lot of the basic development done, and now it's down to implementation and testing.
Okay. And we've got someone that's all the way from Costa Rica, and says, is Mojave available for the Central American market?
I mean, we're happy to sell it there. It's a 120 240 split phase product. So if that's the local grid, then sure, no problem. We are actually doing running a field trial in Puerto Rico. So we're going to learn more about that. But based on what we do know, we expect it to work fine. I don't know about Costa Rica in particular, but it's designed for anywhere with a 120 240 split phase power system. That said, every country is a little bit different in how they require the certifications and grid interconnection and all that kind of stuff. So you'll want to make sure that you don't get blindsided by some requirement that it's got to meet some particular standard that we haven't run it through yet. Which is to say,
Okay,
it
and
probably
let's
worked fine. You just might have trouble with the paperwork.
Gotcha. Okay, I'm going to do one more here, and then the rest I've just taken note, and we can collaborate after on how to get some of these questions answered and to the people who asked them. But once the Mojave has raised the frequency to 64.5 and shut down the grid-tied inverter, at what point does the Mojave bring the frequency back down to 60 and allow the grid-tie inverter to generate again? And hopefully that's not one that requires a super long response, but go for it.
Yeah, effectively it's based on the battery state of charge, as well as other loads that are present. So if the battery is fully charged and shuts down the inverter, and then you activate some other fairly large load in the home, remember, it takes 5 minutes for that grid tie inverter to come back on anyway. So it'll initiate that as soon as it sees that there's a place for that power to go.
Okay. Well, I think we'll wrap it there. I wanted to just send a big thank you to Paul and Chris for this wonderful webinar. I know that the industry has been very excited for this launch, so we're glad to be the first webinar on it here at AEE. So you can exit to all of our attendees. You can exit the webinar at any time, and that survey will pop up, and you can expect the presentation and the link by Monday at the latest. So with that all said, thank you to everyone, and hope you have a wonderful weekend.
Yeah, thanks everyone. And don't forget part 2 with installation, tips and what have you. That'll be upcoming, and Aaron will send out the invitation for that shortly as well.
Yes, thank you, Chris. Yeah, so keep eyes peeled for another email that'll be coming through with the part 2 of this series. And keep me honest, Chris, did you mention the raffle entry? If not, you know what the heck, I'll mention it again. So with this confirmed attendance to this webinar, as well as every webinar in the OutBack Mojave series, you'll be eligible for an entry to win a Mojave. So keep coming back, and we look forward to the next one in March 11th.
Indeed. Thank you, everyone. Have a good weekend.
Thanks so much. Have a great one.
All right, you too. Bye.
Bye.